Okay, so I do want to thank Mike, first of all, for inviting me to join you here today. It is an honor, it is a pleasure. And as we think about our future in technology, the way we see it is that there will be hundreds of thousands of clouds delivering millions of services to billions of devices and things, creating billions of terabytes of data every day. So it is a fascinating future that we are all looking forward to. And we have been, admittedly, talking about the cloud for a very long time. It has been over 5 years that we've all been talking about cloud computing and the move to a cloud architecture. But what I can say today with confidence is three things. First of all, the diversification of cloud offerings will just continue. New services are being born every day. You see it, you're driving it, you're making it happen. These born in the cloud businesses are just going to continue and continue. And we talk about the Super 7, the biggest of the hyperscale cloud service providers, as Mike was talking about, but then there are literally hundreds and hundreds of other public cloud service providers behind them. The second thing we know for sure is that the use of public cloud offerings by traditional IT is on the rise and will continue to grow. So we track it, and over the past 3 years, public cloud service offerings have gone from 75% consumer-centric to now 50%, with 50% being enterprise IT consuming those services. And that will continue to grow. More and more, the public cloud service provider offerings will be consumed by business. And the third thing that we know is that with the realization of the significant benefits that you get from cloud computing, just this fundamental efficiency in cloud architecture to both top line and bottom line results, we know that enterprise will continue to adopt private cloud on-premise offerings as well. They'll modernize their traditional infrastructure onto a cloud solution. And based on the first half of this year's results, or now we're almost done to Q3, we're in the quiet period here, we can project that 20% of all of enterprise IT's deployment of infrastructure in 2016 will be in a private cloud offering, on-premise private cloud. And that's a growth of 20% year over year. So it is becoming a significant portion of enterprise deployment. And there is also, fortunately, greater clarity amongst all of us in when one would choose to use a private cloud versus a public cloud. And there's lots of different criteria, and that criteria is crystallizing. One key attribute for the selection of private versus public is obviously scale. So if, by our math, if you have 1.2 to 1.5 thousand servers under management, you have enough scale to actually run that infrastructure extremely efficiently through the offerings that you heard Mike talk about, through an optimized cloud orchestration solution. Another attribute for consideration that is of increasing importance is data regulation and compliance. So the geographical constraints are going to drive your decision around the cloud. And so these considerations go on and on. And there are also many examples of going between private cloud back to public cloud and public cloud back to private cloud as the different constraints change. Lots of dynamics. And so the good news is that as an industry, we also seem to have stopped debating over whether the world is going public or the world is going private. We all admit that there's no one cloud that is going to serve the massive diversity of requirements. And so the world is going to be a hybrid world. We're going to have lots and lots of public clouds and lots of private clouds. And you can see that today, where each IT organization is going through and rationalizing all of their applications and deciding which of them are core to their business and they want to move to a private cloud, and which of them can move to a public cloud offering and get all the benefits. I used to be Intel's CIO. I was CIO for 4 years, and I did exactly that process of going through the 2,000 different applications and figuring out what we want to actually do with them going forward for a more efficient solution. RightScale, they had their 2016 State of the Cloud report, and they surveyed over 1,000 enterprise IT professionals on their adoption of cloud infrastructure. And on average, businesses stated that they're running applications across 6 different clouds with a pretty even distribution of public and private. So more cloud offerings will emerge. They'll be geographically dispersed. There'll be consumer services, business services, infrastructure as a service, software as a service. It'll go on, and many more private clouds will also emerge, supporting all these new revenue opportunities and just fundamentally making the business more operationally sound. So to deliver on the value, though, the promise of cloud computing, the onus is on companies like Intel and like QCT to maintain a very rapid pace of innovation and deliver on that promise of ever-increasing performance at ever lower cost of operation, the fundamental promise of cloud computing. And so we at Intel are clearly investing to make that happen. We see that as critical and important. We launched back in July of last year our Cloud for All initiative. And that's an initiative that is directly targeted at accelerating the adoption of clouds. Clouds in the public sector, clouds in the private enterprise side. Clouds also for comm service provider market, as Mike referred to. So the telecommunications industry is also moving to a cloud environment because they also need the efficiencies of virtualized network and agile network and the ability to deploy new services. So our stated definition of success in the future world is that you should be able to go from a cloud implementation start to fully functional self-service portal in a day and ultimately in just an hour. So specifically, our actions are to drive the standards for interoperability, as Mike talked about. Open is good, open drives innovation, so we're driving standards so that we have interoperability and portability between solutions. Obviously collaborating with the broad industry to ensure that that software stack is functional and easy to deploy, but then beyond that, making sure that the software stack is also optimized and delivers that truly efficient, agile result that, as Mike said, the hyperscale guys have enjoyed for years. So a big investment by Intel in building out the ecosystem in an open fashion to make the deployment of cloud solutions far easier and more effective. So to really, though, deliver this promise of cloud, which is ever-increasing performance at ever lower cost of operation, we do believe that we have to fundamentally redefine the unit of compute. So we need to move from that unit of compute being the server to the unit of compute being the rack. So you move from local optimization around that server, 2-socket server, 2U box, to the full rack solution, so global optimization of the resources. And then you allow the cloud orchestration solution to decide where to deploy the application based on the best resources available amongst that broader set of server storage and network capacities. So this is what we have coined rack scale design. Rack scale design 1.0 was just launched back at Intel's Developer Forum in August, and we were very happy that it was launched with QCT. We appreciate that for sure. But the rack scale design, then we will continue to evolve it. It'll get better and better, more and more efficient over time. With it, we can do two things. We can deliver higher performance and utilization through the pooling of resources, and we can deliver lower operational costs through a simplified management system running at the rack level and ultimately at the data center level. And we do that through the support of common APIs and common resource management solution. We're also happy to say that VMware is supporting the solution, so we're very happy to have VMware as a partner as well. So with each generation of rack scale design, the performance will increase, the total cost of operation will reduce, and as we deliver this beat rate of innovation, we'll do it across our silicon products, obviously, but then working with industry partners like QCT and VMware, there'll be solutions at the system level, at the software level, and at the solution level. So the next big investment that we have made in improving the overall efficiency of the cloud is in the area of telemetry. So we have an open source project called Snap. Snap enables the scheduling of applications down to the infrastructure based on the knowledge of the utilization of that actual underlying hardware. So what is the utilization of the CPU, of the memory, of the network, of the storage capacity? So what we do is we expose the silicon attributes of all of those technologies up into the orchestration solution and allow the cloud orchestrator to use that for app placement. Now, Mike obviously gave you a lovely scarf, and I also have a gift for you because it's very jazzy now to have a sticker to put on your laptop. So we have, and you're gonna love it, it's the cute little Snap tortoise. It's just absolutely lovely. So you can also give it to your child to put on the back of their laptop. It's very hip. So Snap, with your, Larry's running around, that's very nice of you, thanks Larry. So with Snap, then we're exposing the attributes of the silicon, and you get better placement of your applications. This is something obviously that the big Super 7 cloud service providers have been doing for years through their custom solutions. Google has published lots and lots of papers on their infrastructure telemetry and how they optimize their data center in the placement of their applications and their scheduling of their applications. So we're taking Snap and we're bringing that optimization, that infrastructure telemetry optimization to the masses, out to all of the cloud service providers. So we launched Snap last into open source. So as Mike said, it's all about open source. So we launched Snap into open source last December. There's been over 10,000 downloads. We have Mirantis as a partner is integrated into their OpenStack solution, and we have more solutions coming. So we're integrating that Snap framework into the rack scale design management system as well. So thanks to then the pervasive reach of cloud computing that we're all talking about and the increasing availability of connected devices, we now have millions of terabytes of data being generated every single day. We all know this. And so you hear big data or data analytics, machine learning, deep learning, whatever, artificial intelligence, whatever the buzzword is, it is the big buzz right now. And so you have to ask yourself, why now, right? Artificial intelligence, we've been talking about unremarkably since the 50s, but now it is finally a reality. It is finally here. And there's 3 clear enablers of artificial intelligence and data analytics today. Number 1, it does start with cloud computing. The fact that we have a very efficient way to connect all these billions of devices and deliver out these services. All of these services generating data. Number 2 is pervasive connectivity. So the fact that you can count on secure connectivity, you can assume it's there, and that connectivity is just going to improve in the move to 5G that's underway. And number 3 is, we'll take credit for Intel's Moore's Law. So Moore's Law does allow the ever-increasing efficiency of technology. So it is now cost affordable, it is affordable to now store and compute on these massive, massive data sets. So all of this has brought a tremendous investment then in the algorithms and the techniques for machine learning, deep learning, data analytics solutions. And a lot of it is still in academia, but it is rapidly moving into mainstream. I am really struggling. There we go. Okay, so all of this data enables tremendous opportunity. And we will say that we are reaching the tipping point where data truly is the game changer for all businesses. It's a differentiator. And so while the phrase artificial intelligence evokes lots of strange images of sci-fi, it really is real today. And you can look at lots of artificial intelligence solutions, like talk to text, photo tagging, simple things, fraud detection, quite standard now. What's exciting is to look at the application of artificial intelligence into the next era, the more cutting edge usages like precision medicine, autonomous driving, injury prediction in sports. So when I say artificial intelligence, I am truly encompassing all the compute methods of business intelligence, big data analytics, natural language processing, neural networks, that whole space, that artificial intelligence space is transforming the way businesses operate and how people fundamentally engage with the world. A very exciting space. And so for a wide range of artificial intelligence solutions, I am clearly going to tell you that Intel architecture is the optimal platform. You wouldn't expect me to say anything else. And there is tremendous benefit on running on Intel. So it is a common, consistent programming model. So whether you're building and training that data analytics model, or whether you're scoring the model out against real-time events, whether you're building a scale-up in-memory model or a scale-out distributed data analytics model, you want to have a common development environment, you want to have a common programming language, and you want your development environment to match your deployment environment. And so we will clearly say that Intel is the solution. So for scale-up solutions, we provide leadership with the Xeon E7 or Xeon Phi solutions. For big data scale-out, the preferred solution is Xeon E5 with a Hadoop deployment. Machine learning and its subset techniques like deep learning, they run best on a combination of Xeon Phi and Xeon, or Xeon and Xeon Phi with an FPGA. And it is today the most broadly deployed solution for machine learning and deep learning solutions. By definition, machine learning and deep learning solutions are distributed, parallel, high-performance workloads. The math for deep learning is not new or complex. It's simple linear algebra, matrix multiply. Most of us passed linear algebra in high school, so it's not new, it's not wild and creative. What is new is just enormous scale out. So the more data we know that you can apply to that model, the more accurate the results. And the faster you can train that model and get those results, the faster you have for time to money and time to market. So Intel architecture inherently scales. That's an attribute of the system, and you want to be able to scale as the model grows, as the data increases. The advances in technology efficiency through the cloud architecture and through rack scale design, combined with the increasingly complex workloads that are running, like data analytics and machine learning, make this a very, very dynamic and fun time to be in the tech world. It is a crazy time. However, as you well know, many IT organizations fundamentally don't have the resources that they need in order to develop extensive proof of concepts around these new complex solutions, software stacks, and applications. And as is rational, there's going to be a hesitancy to adopt and deploy new solutions without knowing that they're proven and are going to deliver that return on investment. And so this is why I see such tremendous value in QCT's Solutions Center here. It offers customers the ability and opportunity to actually test drive these new technologies that we talk about. And QCT has partnered with Intel to make that full solution stack available to end users to run their workloads in QCT's lab and prove them out, validate that there is an advantage, and of course then deploy. So it's a very smart approach, a very smart direction, and we're very happy to be partnering with QCT on their labs. So I do look forward to continuing the Intel and QCT collaboration. It's been a lot of fun. We've been working together for decades, and I will say Mike and gang are very well known for pushing the technology edge and being a true leader in the adoption of next generation technologies and solutions. And of course, at Intel, we like that. So thank you very much. Thanks to Mike. Thank you.